Electromagnetic waves. As a definition, an electromagnetic wave is an electromagnetic perturbation or disturbance that is produced by an oscillating charged particle or charged particles. Aside, you can see a table showing the spectrum of all the electromagnetic waves produced or emitted by the sun. We have the radio wave, the microwaves, the infrared, visible light, ultraviolet, X-rays, and gamma rays. As you can see, as we go from the radio waves to the gamma rays, the wavelength decreases, the wavelength which is the distance between consecutive crests. As you can see here, it's long here, however it becomes shorter as we move from the radio waves to the gamma rays. So the wavelength decreases while the frequency increases. You can see that here more number of cycles are being performed. So what are the causes of oscillating charged particles? Could be the bonds holding molecules together vibrate and thus produce electromagnetic waves. These bonds, of course, they are bonds between electrons. Or when electrons drop down energy levels, you know that an atom is made up of a nucleus, including the protons and the neutrons, surrounded with electrons that take different energy levels. So if we have electrons jumping from one energy level to another, it's going to emit electromagnetic wave. Or it could be produced by radioactive decay. The electromagnetic wave propagation. As you can see here, an electromagnetic wave is a transverse wave. Okay, it is composed of two parts, electric field and the magnetic field. That's why it's called an electromagnetic wave. Where did the electric field come from? Where did the magnetic field come from? Innate, a charged particle produces an electric field around it. But when this electric charged particle starts moving or vibrating, it also induces a magnetic field. So this is why we have that the electromagnetic wave includes two parts, electric field and magnetic field. The speed of an electromagnetic wave in vacuum is c equal, by convention, it is symbolized by c equal 3 times 10 power 8 meter per second. You are responsible to memorize this value. Now comparing the electromagnetic waves to mechanical waves. Here when we say electromagnetic and mechanical, this means that these are two waves of different natures. So what's the difference between these two waves of different natures is that electromagnetic waves can propagate through vacuum. And the evidence is that the electromagnetic waves produced by the sun can propagate through the vacuum and reach us on Earth. However, as for the mechanical wave, it could not propagate through a vacuum. It needs medium to propagate through. It requires material to propagate through. And an example of a mechanical wave is the sound wave. It cannot propagate through vacuum. It propagates through a material. Here is a simulation that compares to light wave or electromagnetic wave. So both are transverse. However, mechanical wave constitutes one part, while the light wave has electric and magnetic field. And the representation here of the mechanical wave, on the y-axis we have the variation of the pressure as a function of position. So as a wave propagates through a medium, the particles of the medium are pressed, and as it passes away from them, they go back to their initial position under normal pressure. Application. Consider an EM wave whose wavelength is 640 nanometer in vacuum. Give the speed of this electromagnetic wave in vacuum, then calculate its frequency. As long as I said give, this means that you already know it. This is an acquired knowledge. And I've just mentioned that you have to memorize that the speed of all electromagnetic waves, whether gamma rays, microwaves, X-rays, all of these electromagnetic waves, You have to memorize that they move at a speed of 3 times 10 power 8 meter per second in vacuum or in air. So now C is speed of light in vacuum is 3 times 10 power 8 meter per second. Frequency F equal V over lambda. We all know that V equal lambda times F now because we have the speed and we have the wavelength, so we should use this formula in order to calculate the frequency. F equal V over lambda, 3 times 10 power 8 meter per second over 640 times 10 power minus 9. Why did I multiply by 10 power minus 9? Because I need to convert from nanometer to the SI unit, which is meter. So in order to multiply to convert from nanometer to meter, we have to multiply by 10 power minus 9 because nanometer is much less than meter. And vice versa, from meter to nanometer, we have to multiply by 10 power 9. So now having F is 4.675 times 10 power 14 Hertz, you are asked to deduce whether this electromagnetic wave is visible or not. So in order to determine whether this electromagnetic wave is visible or not, I have to go back to the visible spectrum. Visible light is from 3.75 times 10 power 14 Hertz till 7.5 times 10 power 14 Hertz. And the abbreviation for the visible spectrum is RHS, where R stands for red, O for orange, Y for yellow, G for green, B for blue, I for indigo, and V for violet. So RHS is the abbreviation of the visible spectrum in increasing order of frequency, or we can say in decreasing order of wavelength, because the wavelength and the frequency are inversely proportional. So now going back to the question, you were asked to determine whether this wave is a visible wave or not. All we have to do is compare or to check whether it belongs to the range of visible spectrum. So 4.6875 times 10 power 14 Hertz is greater than 3.75 times 10 power 14 Hertz and less than 7.5 times 10 power 14 Hertz. So yes, it is visible. Knowing that the frequency of any wave doesn't change as it propagates from one medium to another, calculate the wavelength of this wave in water. In this exercise, I gave you the hint. I told you that the frequency of the wave doesn't change as it propagates from one medium to another. But for the exam, you are responsible to know this idea, and you have to make use of it whenever needed. So calculate the wavelength of this wave in water. Given that the speed of light in water is 2.3 times 10 power 8 meter per second, we can apply the formula V equal lambda times F, and thus divide both sides by F in order to obtain lambda alone. So lambda is V over F. Substituting 2.3 times 10 power 8 meter per second over 4.6875 times 10 power 14 Hertz, we get the answer in the SI unit because both the speed and the frequency were substituted in the SI unit. So the lambda here is in meter, 4.9 times 10 power minus 7 meter. Now to be able to compare it to the wavelength of this wave in vacuum, we have to convert it to the same unit. So given that the wavelength of this electromagnetic wave in vacuum is 640 nanometers, so let us now convert the wavelength in water into nanometer. In order to do that, we have to multiply by 10 power 9 as shown here. So we take the result, 4.9 times 10 power minus 7 times 10 power 9, and it's equal to 490 nanometer.